this was very unusual question when it comes to complex number. And look, that's the reason why I'm always saying to all my students, I'm saying, look, the more exam question you do, the better you become. That's the key, not only in maths, but in every other subject. Okay, so here we have that there is z, and they are giving us a z, and it is a root of equation. And then the problem we are having here that is a cubic equation. And they are saying find the other two roots of this equation. One should be complex and the other one should be real. So the reason why they are saying that the other one is complex, let's remember something about the equations and the roots. So my coefficients, -2, -14, plus 1, they are all real values, isn't it? So when we have all coefficient numbers are real, that means that root of that equation will be the complex number and its conjugate. Okay, so that means that my one complex number, one root, as they say, is 3 minus I, and then the second one is the conjugate of it, so 3 plus I. So definitely I did find one of the roots. Now I just need to find the third root. Okay, now I know they can be a little bit confusing because it's complex number, but pause with me for a minute. If it wasn't a complex number, if it was just ordinary cubic equation, we know we can do comparing coefficient. And that's the same thing I can do here, because it's going to be a linear factor, meaning x to the power of 1 multiplied by quadratic. And that will give me the cubic outcome, isn't it? Cubic equation, because x multiplied by x to the power of 2 will give me x to the power of 3. Now, pause for a minute. Like I'm saying, the fact that it's complex number, the idea is the same. So when it comes to that quadratic one, well, we have this additional knowledge when the coefficients are real, that is saying z to the power of 2 minus what? Sum of roots besides z plus, and then product, bracket product of roots. So using that knowledge, I can identify my quadratic factor here. So that means sum of the roots, that will be what? 3 minus I plus the second root, 3 plus I. So what do I have here as sum of the roots? So I simplifies out, 3 and 3, that's 6. Product of roots, let's multiply 3 minus I multiplied by 3 plus I. So we know that is when I have two brackets with the same element, and only difference between them is plus and minus, that equal the first number to the power of 2 minus the second number to the power of 2. In our case, that will be 3 to the power of 2, which is 9, minus second number to the power of 2, that is I to the power of 2, and I know I replace that with minus 1, so I have 9 minus minus 1 in my calculator, and I get 10. So my quadratic root will be z to the power of 2 minus the sum, which is 6z, plus the product, which is 10. And then I have the cubic 2z2 minus 14z minus 40. Now, what about my linear? If it was normal, like I'm saying, forget about complex number. What will I have here? I will have x plus, let's say, not to confuse, let's put letter d. Isn't it? Now, because it is a complex number and the roots are complex, so all I'm going to do, I don't have x, I have what? Z. So that's what I'm going to have here, z plus d. And really, all I need to find at this stage, because I have already two roots, I just need to find that one, that d value. Okay, now, what do? We do the multiplication. Honestly, we don't have to do all of that multiplication, but anyway, let's do so that you understand. So z by z to the power of 2, z to the power of 3, z by minus 6, z minus 6, z to the power of 3, 2z by 10, that is z by 10, and then multiplication by d. So z squared d minus 6dz plus 10d. And then my cubic equation on the other side. Since all I have to do is to find d, look at that. All I need to do is to take 10d is equal to, actually not minus, is that not plus? Look at me. Plus and minus will find me out. So that means 10d is equal to 40 on the other side. So if I want d, I divide both sides by 10. So that means my d is 4. So my other factor is z plus 4. So that's the factor. If I change the factor into roots, what do? I equal it to 0. In this case, move 4 to the other side, so it's minus 4. So that is my third root. Yeah. So comparing coefficient have such a big application. That's what I'm saying. Yes, you could do, if you are thinking about long division, yes, of course, you could do long division here as well. It will work. I'm not saying that it will not. However, that was very interesting take on the complex number idea.